Hi students, good morning all. Myself, M.M. Dikshit sir. Our name of our first chapter is Rotational Dynamics. So, write down name of the first chapter, Rotational Dynamics. Rotational Dynamics. Now, prepare your notes while watching this video. The next point is its introduction. So, please write down the introduction simultaneously. The rotational motion the rotational motion and the rotational motion and the circular motion. Write down simultaneously. Rotational motion and the circular motion. And the circular motion the rotational motion and the circular motion are very essential are very essential parts of essential parts of our life are very essential parts of our life. The year is due to the circular motion The year is due to the circular motion of the earth and the day is due to the rotational motion and the day is due to the rotational motion. Therefore study of these phenomenons is very important. Therefore, study of This phenomenon is very important. Write down this first paragraph and prepare your notes simultaneously. Now in the next paragraph of this introduction, we are going to form two parts for our simplicity. So write down the next part. For our simplicity, we form two parts. For our simplicity, we form two parts of this chapter. We form two parts of this chapter. Circular motion, such as circular motion and rotational motion circular motion and rotational motion. So write down the first part first. Circular motion. In bracket, that is C dot U dot. Now the circular motion is our first part. Even if the definition is already studied in the 11th standard, let us know about this definition. The motion of the particle. Write down this definition. The motion of the particle. The motion of the particle. Motion of the particle along the circumference of the circle, along the circumference of the circle, write down this definition, is called circular motion. Is called circular motion. For example, first write down the first example. The motion of Earth around the motion of the earth around sun, and the second example is the tip of a hand of a clock. The tip of hand of a clock. The tip of hand of a clock. So this is our first part, the circular motion. So we are going to study the points in this first part of the chapter. So write down the first point. So this is a part first, and in which it is a first point. So write it as a first and 1. Now this point is the characteristics of the circular motion. So write here characteristics. Characteristics of the circular. I would like to write it in short form. The characteristic of the circular motion. This is our point, characteristics of the circular motion, in which very important question will be asked. So write down this question Q, and it is IMP question. It will be asked for 1 or 2 marks. 1 or 2 marks. Write down this question. This question will be asked for 1 or 2 marks. Here. Write down this question. Give the characteristics. Give the characteristics of the circular motion. Give the characteristics of the circular motion. The answer is only in 2 sentences. First is, write down the first point of this answer. The circular motion is an accelerated motion. 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 Please prepare your notes while watching this video. Circular motion is an accelerated motion. Because the linear velocity, because the direction because the direction of linear velocity changes, because the direction of linear velocity changes in circular motion. Now, because the direction of the linear velocity changes in circular motion, changes in circular motion. Now, the second point of this answer is circular motion, especially UCM. The circular motion is a periodic motion. The circular motion is periodic motion. Write down, the circular motion is a periodic motion. The circular motion is a periodic motion. Because in UCM, the period and frequency of the particle is constant. In UCM, the period and frequency is constant, because in UCM the period and frequency is constant. The period and frequency is constant. Now the first point of the first part is the characteristics of the circular motion, and the next point of this first part is the kinematics of the circular motion. So write down the second point of the first part, kinematics of the circular motion. This is the second point in the first part. Write down, kinematics of the circular motion. Kinematics of circular motion. Kinematics of the circular motion. Write down, kinematics of the circular motion. Kinematics of the circular motion. Now the question is also IMP question. It will be asked for 1 or 2 mark. So write here question. Give the kinematics of the circular motion. Now what is the kinematics? What is the kinematics of circular? Write down simultaneously. What is the kinematics of circular motion? Question. What is the kinematics of the circular motion. This is the question. What is the kinematics of the circular motion? What is the kinematics of the circular motion? Or another question is, will be also asked, explain the analogy of the physical quantities in circular motion and linear motion. Explain the analogy between circular motion and linear motion. Analogy between circular motion and linear motion. Now, for the answer of write down the answer, or for the answer of this question, write down the question first and the point. Then for answer, the points shown on the board should be removed. So write down the answer. In answer, let us see first what is meant by kinematics. Now, the kinematics of the circular motion, the kinematics of the circular motion, the kinematics of the circular motion is the study of circular motion of circular motion. The kinematics of the circular motion is the study of circular motion. Without considering the action of force on the body. Without considering action of force. Without considering action of force. Now, in the answer, we see the first point, what is meant by kinematics. Then, we are going to understand the kinematics by considering the table, or by using the two columns of a table, in which please draw the table in which there are two columns. Means, please draw this table. First column is for circular motion. And the second column is for linear motion. Please draw this table. Circular motion and the linear motion. Now the first point is angular displacement. Angular displacement. This is the first physical quantity which is used for the study or description of the circular motion, and it is denoted by theta bar, angular displacement. Now the angular displacement, it is used to describe change in position. It is used to describe change in position, change in position. Angular displacement theta bar, it is used to describe the change in position. SI unit is now the physical quantity in linear motion is linear displacement. Linear displacement S bar. Linear displacement S bar. It is used to describe the change in position. It is also used to describe the change in position. It is used to describe the change in position. And unit is meter. If I move from one point to the another point, then this movement or change in my position is described by using linear displacement S bar, and if the distance between the 2 points is 5 meter, then my displacement is 5 meter. Similarly, for the angular displacement theta bar, if the angle traced by the radius vector is 30 degree, then the angular displacement is 30 degree in a given time. We are going in these two tables, we are going to understand how the physical quantities in circular motion and linear motion are used for the study or to describe these two phenomena. Now this is the first point. Now write down the second point. The second point is angular velocity. Angular velocity omega bar. Angular velocity omega bar. Now it is used to describe the change in how the displacement changes. So write down only its a formula and unit. Its formula is omega bar is equal to d theta bar divided by dt, and unit is radian per second, and this quantity is used to describe how the velocity, how the displacement changes in a given time. Now, the physical quantity in the linear motion, which is analogous to the circular motion, to the angular velocity, is linear velocity. Linear velocity v bar. Linear velocity v bar. Now the formula for linear velocity is v bar is equal to ds bar divided by dt, and unit is meter per second. This linear velocity is also used to describe how the displacement changes, slow or fast, how I move, slowly or fastly. It is described by using a linear velocity. Now, by removing first and second points in the given table, write down the third point. Third point for these two phenomena is, this is the third point, angular acceleration. Angular acceleration alpha bar. Angular acceleration alpha bar. Now the formula for alpha bar is equal to d omega bar divided by dt, and unit is radian per second square. Now it is also used how the velocity changes. It goes on increasing, goes on decreasing, or goes on changing. It is described by using angular acceleration. Now the analogous quantity is in the linear motion is linear acceleration. Linear acceleration. A bar. It is simply termed as a only acceleration, A bar. Now it is also defined as the rate of change of linear velocity with respect to time, and so the formula is A bar is equal to dv bar divided by dt, and unit is meter per second square, and the unit is meter per second square. Now, in order to understand the analogy between the circular motion and the rotational motion, in order to understand the analogy between circular motion and linear motion, we draw this table. Now, this table shows that the physical quantities in circular motion are analogous to the physical quantities in the linear motion. So, after the table, write down, it shows that physical quantities in circular motion are physical quantities in circular motion are analogous. The physical quantities in circular motion are analogous are